Good morning, everybody. How you doing? Good morning. My name is Matt. It's a pleasure to take some time today and chat with you all, just 5,000 of my closest friends. I'm going to talk about generative AI. No surprises there. And I'm going to try and convince you that there is a remarkable opportunity ahead of us all to scale, succeed, and shake up generative AI. This always seems to get left to the end, but thank you for your attention. I know you have a million emails in your inbox, and you could have been anywhere in the world, but you're here with us, and myself and the rest of the team here really appreciate it. Thank you all so much. Now, generative AI is probably the single largest shift in how we're going to interact with data and information and each other, probably since the advent of the very, very earliest internet. And organizations that invested in the early internet 30 years ago, like Amazon.com itself, went on to experience pretty tremendous growth in the intervening decades. And it's my estimation that customers and organizations that are investing in generative AI today are going to experience multiple Amazon.coms of growth in the next 30 years, or even sooner. Now, over time, technology tends to follow an S-curve in terms of its capability. You start off at the bottom left-hand corner, you make slow incremental improvements until you hit some sort of inflection point. And at that point, you get a high gradient increase, an exponential increase in the capability, until that exponent starts to decrease, and you end up with what you've got with only kind of diminishing returns relative to the capability. Now, there are, I think, some out there today that would suggest that generative AI is already at this top right-hand corner, that what we've got today is pretty much what we're going to have to work with for the foreseeable future, with only small incremental improvements. I do not believe this to be the case. I think many more people would say that we're over here in this high gradient part of the curve, where there are new techniques from academia, from industry groups, from the public and the private sector, new models and techniques appearing virtually every single day. In fact, I am sure that by the time we finished our time here together this morning, there will be new methods and models worthy of our attention. It's incredibly fast moving. But for my money, I actually think we're over on the left-hand corner of this curve. I think we're just getting started. I think that we're in the very, very earliest stages of this technology, and that we haven't yet hit that hockey stick inflection point as to the increasing and incredible exponential increase in the capability of this technology. Now, that being said, it's obviously still evolving at an extraordinarily rapid pace. There's new approaches appearing all the time. And so as leaders, maybe inside large organizations, maybe leading a team, maybe we're leading our government organizations, maybe we're leading our startup, whatever it might be, we face a question. Where and when should we invest? If you invest in capabilities too soon, then you may, in these cases that are so fast moving, when there's a pace of discontinuous change, you may end up investing in a technology which is quickly overtaken by something else. And if you wait too long, then you could end up investing in something after that exponent hits and you miss the opportunity. And those organizations that are going to experience the most significant growth going forwards, I think are probably likely to be the ones that make this high judgment decision correctly. Where should you invest your precious resources, your people time, your compute time, in order to get the absolute maximum return on that investment? Now, one way to do this is to try to look for these potential snowball events, areas and techniques and technologies which are starting to move in a way that they are building their own momentum, and that momentum will grow the more that they are used. The trouble is that this is incredibly difficult to do. When you're on these S-curves of capability, you only get to look backwards down the curve. And it's very, very difficult to try and predict when that exponent would occur. Even worse, these exponential increases in capability are extraordinarily rare. And they're very, very hard to predict as a result. You only really get a handful per generation. But I think there's one almost right around the corner for generative AI today. And the good news is that there are a few telltale signs that if you know what to look for, make it much easier to find these events, which are almost black swan events. And we can look at these through history. There haven't been that many, but we can look at where they've occurred. And they almost always start with the discovery of a new technology which improves the utility and performance of a particular task. And you can see this with the very earliest agriculture, when folks started to use tools, something as simple as a wooden stick, instead of planting seeds with their hands. And this discovery, the use of tools, enabled those that were using those tools to operate with much higher utility and much higher productivity as a result. Now, over time, those tools start to get more and more specialized. And the deeper the specialization goes, the more the tool becomes useful for individual tasks. And you can see this too with agriculture, as those sticks turned into rakes and hoes and all sorts of specialized tools for planting individual types of seeds and growing individual types of crops. And the third indicator is that you really want to look for increasingly collaborative systems of work and play. And what you see over time is that as all these different tools became more specialized, farms started to grow up around their usage. And those farms were much more capable at growing a large number of crops than any individual farm for any individual crops. They were able to take advantage of their economies of scale in order to be able to operate much more efficiently. And then, of course, this is a feedback loop which tends to drive more invention and more discovery over time. And we've seen this play out a couple different times in the past couple decades in technology. You can think of the browser as a very first discovery, a new tool which allowed us to operate and communicate more with higher performance. Over time, we added more specialized tools, web apps, SaaS applications, which ran typically inside those browsers. And then those SaaS apps started to talk to one another through the use of APIs, such that when you added a new SaaS app to your portfolio, all of the existing SaaS applications became stronger and more productive, and you could take advantage of the economies of scale because they all talk to each other through these APIs. We saw it with mobile as well, where the mobile phone arrived. It was a pretty awesome discovery. It was useful and productive on its own, but when we started to add apps to that, the devices in our pockets became better and stronger as we added each incremental app. And over time, automation and integration between those applications meant that every new application meant all of your other applications got new capabilities as well. And so this is the sort of pattern that I think we expect to see playing out with generative AI going forwards. So let's take a look at how it may play out. The discovery that I think we're all aware of is of these brand new generative AI models that come in all shapes and sizes. And I really do think of these as a discovery and not an invention. We have discovered that if you take these very, very large mathematical formulae, you pipe lots of data into that formulae, then they start to exhibit these strange, emergent behaviors which get close to mimicking human intelligence. This is a new discovery, a new software tool that we just haven't had before, and it allows us to start to provide reasoning and integration into our software in all different sizes and shapes. And what we've found in the past 2 years experimenting with this inside the company at Amazon is that there is no one model to rule them all. We see this play out at the company at Amazon. We see it play out with our customers as well. Hundreds of thousands of them are building on AWS today with their generative AI workloads. And the reason for this is that each different model has slightly different sweet spots. They have different use cases that they're good at. Some are good at summarization, analysis, reasoning, code interpretation, or they have different operational characteristics. Some of them are really, really fast. Some are low cost. Some are incredibly intelligent. And being able to pick the right model for the right use case is a really important first start to start using that to drive up utility and productivity using this new discovery. And it's what drove the insight with the Amazon Bedrock, which is our service for building generative AI applications, where we provide a very, very broad number of models available from ourselves, along with folks like Anthropic and Cohere, Meta, Mistral, Stability, and more over time. Now, with each of these frontier or foundation models, when you start taking them off the shelf, what you find is that they've all been trained on an internet of data. They've got an incredibly broad set of concepts and relationships available to them. But it's pretty thin. It's a veneer. And most organizations and teams, they operate at depth. And when you get to that depth, these models are much more like Swiss cheese. They've got areas of information density, and they've got areas of information sparsity. And part of the role of specializing these models is in helping them plug those gaps of information sparsity, removing the Swiss cheese holes, and guiding the models such as they find the areas of information density. This drives up accuracy and drives down the mistakes that can be made through hallucinations. And you do this by contextual grounding. You take data that the models haven't seen yet, information which is private to your organization, and you start to ground the model in the reality of your own business, in the reality of the problems that you're trying to solve. And then you add guardrails on top of that. You start to specialize the model by telling it what it will and what it will not answer questions about, what types of information it has, what types of information it does not have. And you can steer the discussion that way and reduce the amount of errors that are made. And finally, trust is incredibly hard to build and incredibly easy to lose. And so you want those results to be genuine. You want them to have a high relevancy to the question that's being asked, and you want to be able to detect hallucinations when they occur, such as you can either flag them to the user or stop them getting to them in the first place. And so these three concepts, groundedness, guardedness, and being genuine, contribute to the opportunity to take these broad, general knowledge models, world models, and apply them to more and more specialized tasks. And one of the most interesting and exciting specialized tasks that we've seen is the use of specialized autonomous agents. These are agents where instead of just asking a question to the model and using the specialization of that model to get an answer, you actually start out by setting and defining an objective. And you ask the model not to answer, but to divine a plan of how to meet that objective. And then automatically follow that plan like a to-do list, execute against the items on that to-do list in order to be able to deliver the objective. And at the end, know whether you have successfully completed that objective or not. And if you have, great, thumbs up, everybody goes for lunch. If you don't, you feed back what you've learned, update the plan, and continue to iterate. And this allows you to take all of the specialization that we just talked about, take a world model which is incredibly capable at reasoning, specialize it by grounding and guarding, and providing genuine, honest results, and start to use it to drive autonomy inside your organization, to start achieving objectives. Here are some really, really simple ones. You could set up a writing agent where you could set an objective, something like expand this outline into a first draft. And instead of just taking that text and expanding it out like a large language model might do, you can ask it to form a plan. And the plan might have expanding this text from bullet points, finding the citations, assessing the speller and grammar, doing some editing, reviewing, editing for style, those sorts of things. And the agent will go off and it'll start to execute against that plan and not just take what you've got and rewrite it in a single pass, but process the information in a little workflow, step by step, in order to be able to deliver a much more high value or level of autonomy. You could also book a travel trip using an agent. You could help me book a vacation somewhere tropical, under 8 hours by plane, with a rented car and a 4-star hotel for under $2,000 total. And the agent won't just try and look that up on the web. It will use web information plus other grounded information, plus its own guardrails, to be able to start to build a plan to help you deliver on that objective. And we've seen this to be incredibly effective specifically for software development. And so these language models are amazing at writing code. You can provide a comment and assistant, such as Amazon Q, which is an assistant specifically designed for builders, will start by taking that information, and it will start by generating the code and the tests and all those sorts of things. And you see a pretty big jump in productivity for software developers that way. But once you start to add agents and agentic objections to this approach, productivity doesn't just double, it increases by an order of magnitude. And so we have agents inside Amazon Q where you don't just ask for code, you can say, hey, I want to add this feature to this code. And Q will not just try and generate that feature, it'll look across all of the code inside your development environment. It'll look at all the code inside your repositories. It'll look at all the code inside your organization, and it'll start to learn the coding standards and the internal APIs that are available to you. And then it will write an execution plan. It'll say, hey, I need to update this code. I need to write this code. I need to write these tests. I need to write this documentation. And let's see how we get on. You get a chance to review that and then let it run on its way. It takes about 10, 15 minutes usually. And then what you get back is a series of pull requests you can very quickly start to add to your task. So this takes the art of typing, which used to be the majority of time that we spent actually interacting with computer systems, and turns all that time typing into time that is spent thinking. And in the future, it's my estimation that you'll spend more time thinking and the agents will do the typing for you. And as a result, you'll be interacting with not 2 or 3 or 4 different agents, but dozens of different agents, orchestrating them in interesting ways to solve higher order problems. Now, all of this is interesting, but agents are kind of like the apps for generative AI, in that as you start to add more agents to your intelligent systems, the existing agents start to get more capable if those agents can interact with one another. One area that we found to be incredibly exciting is the opportunity to supercharge this level of autonomy, not by working with a single agent or manually orchestrating dozens of different agents, but by having the agents orchestrate and manage themselves in what we call multi-agent systems. And there's different ways you can architect for this. Some of them are hierarchical. So you can have a leader, and that is basically an assistant which will drive the other agents. So you may have specialists that are good at software development or database optimization or building in the cloud or understand your business in a deep way or understand your metrics, whatever it might be. And one centralized agent will farm out the tasks to those different agents, pull back the results, and then tell you how it's getting on. This is really useful if you've got a task which is pretty well understood how to get from A to B, how to meet the objective. So this would be really useful if you wanted to add features to code or if you wanted to book a flight, something where the steps are pretty well understood. But there is a class of problems which are much more ambiguous, where the path to get from A to B is not well understood. This would be something like, I've got $100, turn it into $1,000. There's all sorts of ways that you could go about setting that up. And so we've also found that peer-to-peer agent orchestration is super interesting and super compelling. And here, the agents aren't acting through a centralized command and control system. They are acting independently and often voting on the output. They can act collaboratively that way. We've also found that teams of agents can act in competition with one another, and they can start to compete for the objective, driving all sorts of interesting activities. And of course, you can mix and match these different hierarchies, so you can have a centralized controller working with multiple different peer-to-peer networks, those sorts of things. And we've done a lot of work and research in this area. One that I'll just call out is a paper we published not too long ago, well worth the time to take a look at, pretty well read, well written in my opinion. And it shows that you can solve much more complex problems with multi-agentic systems than you can with any one agent, and that the results are much higher in accuracy and have much lower error rates. And we're also seeing startups start to approach this as well. I want to give a shout out to my friends at Ninja Tech. This is my preferred AI system. It has one interface to multiple agents under the hood. So they have researchers, they have schedulers, they have assistants, and all of these agents can work together to solve much higher order problems. And this is where I spend vast majority of my time when I'm doing my own research, including some that contributed to this talk. So the generative AI models, the ability to be able to specialize those models and harness the power of that specialization into autonomous agents, and then combine those agents together allows us to start to creep closer and closer towards the exponential growth of the hockey stick moment for generative AI. And so I suspect that we're somewhere in this pink box here right now, where we have this amazing opportunity ahead of us. And for those of us that are making strategic investment decisions, this is promising to be an incredibly rewarding one with a high ROI as more and more agents develop and multi-agentic systems start to mature. So a high opportunity area. It's one that we're helping to drive at AWS by adding additional capabilities to our Bedrock system, which allow you to do much longer planning and execution, to be able to allow the agents even to be able to write code which runs in a sandbox. And we've got a very, very large body of work which is starting to be published now in this area about identifying hallucinations, driving up accuracy, and building out these multi-agentic systems which are much more capable and stronger than the sum of their parts. If you want to get started, I highly recommend you check out Bedrock. You can do this without writing a single line of code and get your first agent up and running using something we have called prompt flows, which is available today. You don't even have to write any code. You can have your first agent up and running in less than 5-10 minutes. And so I really cannot wait to see what you'll build as a result. And with that, thank you very much for listening. Appreciate it.